All right, today we're going to be talking about polynomial graphs and analyzing them a little bit more. So we're going to graph polynomial functions and locate their zeros. We've done that before just with quadratics, but it's the same idea. And then we're also going to find the relative maximums and minimums of polynomial functions. Again, we've done that with quadratics. So some new vocabulary is relative maximum. It's the highest point in an area. Now, when we did quadratics, they were just a U-shaped graph, so there was only one max or minimum. Now, when we have multiple hills and valleys, we can have relative maximums and minimums. We can have multiple of each. So we can have a relative minimum, that's the lowest point in an area. The absolute max is the highest point for the entire graph, and the absolute minimum is the lowest point for the entire graph. So there should only be one absolute max and only one absolute min, if there is one of those. But there can be multiple relatives. All right, location principle. If we have two numbers, and what this means here, you can read this if you like, but if we have a number that's below the x-axis, a negative number, and we have a number that's above the x-axis, or a positive number, somewhere in between those two, we have to have a zero. So as this graph goes, to go from a negative to a positive, we will have to cross zero. That's what the location principle says. So we're going to be worried about trying to find zeros. So this will help us find the zero, because if I know that this point is negative and this one's positive, there's got to be a zero in there somewhere. Likewise, if we have a positive going to a negative, there would be a zero somewhere in that value also. That should make some sense. All right, graph this equation by making a table of values. Well, we can use our calculators and go ahead and graph it. You can type it in and then zoom 6 to look at the graph, and then second graph to look at the table of values. Here's a table of values that you should get for there. And here's a graph, and if you plot those points on your piece of paper, it should match what your graph has. And notice this is a degree of 3, so it is an odd graph, so one goes up and one goes down in terms of end behavior. And notice we have some zeros here. We have some zero, one here, and one here. Zeros, remember, are where we cross the x-axis. If we're looking at our table here, notice this number from 5 to -4. Somewhere in there will be a zero. That's what the location principle says, because it goes from a positive to a negative. Here, from a negative to a positive, there'll be a zero in this area, and this zero just means that it is the zero. So there are 3 different zeros, and you can find them in those different locations. Now we can use our calculators to go ahead and do that. Now this also has a relative minimum down here somewhere. There's a lowest point in this area, and there's a relative maximum up here, and this one looks like at 0,5. That one looks pretty simple. This one we might have to get the decimal approximation for. But those are relative. There are no absolute, because these lines keep going on forever. Odd numbers will not have absolutes. Odd degrees will not have absolutes. It's the even ones that will have absolutes. All right, so we talked about end behavior. So as x is going to the left, what do we know about the graph? It's going up, so we write a positive infinity. As x is going to the right, it's going down, so negative infinity. And again, 3 zeros, as we kind of talked about. So what's the graph of this one? We should actually be able to do this without even typing this in. Degree of 3 means that it has one going up, one going down. This is an even degree, so that can't be it. This is also an even degree, so this one can't be it. So it's one of these two. And then if you remember from yesterday, we look at the leading coefficient, which is positive, and positive means it goes down and then up. This would be a negative leading coefficient, from the negative being up to the positive being down. But negative, negative, positive, positive is definitely, it's going to be C. Now, just looking at some of these other graphs, again, this would have a minimum here, a maximum there. It would only actually have 1 0. The same thing, a maximum here, a minimum here, and only 1 0. This one has 2 zeros here and here. This would have a relative max here, a absolute max here, because that's the highest point, and this is a relative minimum. and it would have no absolute minimum. This one here would just have one absolute minimum and no relative, or no maximums, and no zeros. So just kind of looking at the different graphs and how it goes. And of course, our answer is C here. All right, now let's go ahead and find the zeros. So we go ahead and type this in our calculator. And we should know, because it's an even, it's going to have an even number of zeros. So 0, 2, or 4. So here's the graph of it. And we should be able to already tell kind of where the zeros are going to be. Between 9 and -1, there's going to be 1 there. And between -1 and 1, there's another 1. Between 1 and -3, and -7 and 19. Whenever there's a sign change, we know that there's going to be a 0 there. So we're actually going to have 4 zeros because of all those change in signs. So let's take a look at the graph, and here's our graph. And so we need to go ahead and find these points. So we go second calc, 0. And so we have that first one, -2, -1, between -2 and -1. And when we use our calculator, the actual answer is -1.44. 2 decimal points is fine enough for me, is what I would like you to go ahead and do. And then -0.57, 0.49, and 2.52. All right, determine the zeros here. Well, we have 1, 2, 3 zeros. One's between -1 and between 0 and -1. It's at -0.66, between 0 and 1, 0.79, and between 3 and 4, which is 3.87. So you should be able to find all of those. We also should be able to find the maximum or minimums. Again, that's second calc on your. We have a relative max here and a relative min here. So we're going to go ahead and use our graphing calculator like we've done before. You put it into y equals, and then we go to the calc menu, and we're going to select maximum or minimum. Remember, you have to do the whole left bound and right bound thing. We've talked about that before. And hit enter twice, and you're going to get these two depending upon maximum here and minimum here. Now remember, whenever you have this e-6 kind of a deal, that's just 0. So we have a maximum at 0.5, and we have a minimum, again, just round this. There's some issue with the program and how this works. So this is just 2, 1. So 0.5 is the relative max, and 2, 1 is the relative min. And you should be able to do those by now. All right, so what about this one? We have a max here and a minimum here. So the relative minimum is 0.2. That was easy. You could, both of these, you could probably just look at it. 0.2, and then -2.6 is the relative maximum. That's what I have for you today.